Okay, so we're going to use the derivative function of f to find the intervals on which f is increasing or decreasing. This could be a paper 1 question, so we're going to do it completely algebraically, but it's probably better to do it with a visual, okay? So this is our function 2x cubed minus 3x squared minus 12x. X is increasing towards the right, so what is this function showing us? Okay, so from this point here, the function is increasing until it gets to this point, and then it starts to decrease until it gets to here, and then it's increasing. So the gradient is positive, then negative, then positive. Okay, we're interested in finding these points, this point and this point, because these are points of intersection and they turn up algebraically. Okay, so if we look at those points, that point is negative 1, 7, and our local minimum is 2, negative 2. We're not really interested in the y values, only the x values. Okay, so as we move towards the right on this function, we can see that it increases up till negative 1, it decreases to 2, and then increases from 2. Alright, so that's what the question is asking. What is this graph doing, but can we show this algebraically? Okay, so the first thing we're going to look at is the first derivative. If we differentiate the function, we're going to get 6x squared minus 6x minus 12. Okay, power rule it, and then you're in a good position. This is the gradient function. Okay, this is, if we plug numbers in to this function, we get the value of the gradient. So if we plug x is negative, we're going to probably get a positive answer. Okay, because we've got an increase in function. At f prime of 1, we're going to get 0 because it's a turning point. Then after that point, it's going to start being negative until we get f prime of 2, when it's going to become 0 again, and then it's going to go positive again. Okay, and that's the crux of this question. We have to be able to do this completely algebraically. All right. Next, so if we have our derivative function, this is what it's doing. As I said, you plug a number in, you plug a small number in, a negative number, you're going to get a really big positive value, and this gradient function is decreasing. The graph, our original function, isn't decreasing, it's increasing because it's still positive. Our function here is still above the 0 line on the y. Okay, remember this is y equals 0. And that's talking about the gradient. The gradient at this point is 0, so I should really call it m. Yeah, m is 0 here, and above in this area we've got a positive gradient. Down here we've got a negative gradient, and you just have to be able to fight with that. Okay, so algebraically we've got f prime of x is equal to 6x squared minus 6x minus 12. Common factor. Let's take 6 out, so we're left with x squared minus 2. We can factorize this function as well, so now we've got x minus 2 and x plus 1. If we're lucky, okay, the solutions, this value here should be that point. So that should be x is minus 1. And this value here should be the other solution, x equals 2. Okay, so that's where we're at with this. So if we factorize the derivative function, we should be able to find the zeros, which are the points at which the gradient is either positive or negative and switches between. Okay, let's just have a look if we do that on the GDC. Boom, yeah, negative 1, 2. And why is this point interesting? Well, we'll come to that point in a second. Okay, so those are the visuals. Let's get there completely algebraically now. Okay, so, we'll come back to that in a second. Right, so our function is f of x is 6x squared minus let's just go with f prime. Let's just say we're there already, okay? And we factorize to get x minus 2 and x plus 1. So we know the gradient is doing something as x increases, okay? So let's look at x. As our values of x increase, we know at -1 it's 0. We know the gradient is 0. At x is 2, we know the gradient is 0. Okay, that's because we've got those points of inflection of our original function. So what's happening here? Let's just pick a number that's less than -1. Okay, we could pick something that's really close to -1, but I'm just going to pick, we're going to work out f prime of 2. So f prime of 2 is 6 times -2, -2, my bad, squared, minus 6 times -2 minus 12, which gives us 6, 12, 18, 24, plus 12 minus 36. No, minus 12. Sorry. 36 minus 12 is 24. Okay, so that on this side we've got a big positive gradient. What's happening after -1? So let's try f prime of 0. F prime of 0, 6 times 0 squared minus 6 times 0 minus 12. It's negative. What's happening at, so we need a value after 2, so let's pick 3. 6 times 3 squared minus 6 times 3 minus 12. 954 minus 18 minus 12, that's going to be positive again. Okay, so the gradient function is telling us our graph, our function is going to have a positive gradient until here, where it's going to be 0. Then it's going to be a negative gradient, so it's going down until it gets to here when it's 0. Then it's going up again. So it's going to have a positive gradient, and then it's going to come down again, and then it's going to go up again. Okay, so we're nearly at the solution to the question. So we found those zeros, the zeros here when we're factorizing that. We know from the null factor law what those points are. We can test a value before one of the zeros, after, and before, or wherever in relation to the zeros to find out what's going on with the gradient before and after. So our function f of x equals 2x cubed minus 3x squared minus 12x. We know it had a positive gradient, okay, so it was increasing. Our function is increasing at the beginning, okay, so for the values x such that x was less than -1. That's also true when x is greater than 2. Okay, so to the left hand side it was increasing, and to the right hand side it was increasing. We know it was decreasing for the set of values where x is such that x is greater than -1 and less than 2. Oh, I can never draw those, even when I try. Okay, let's try again. Okay, so here the value is decreasing. It's stationary, i.e. not changing, when x equals -1 and x equals 2. So what does that look like visually? Okay, so if we go back a few, so the red is our gradient function, the blue is our function. Okay, so the function is increasing. The red has a big positive gradient. When the red equals 0, that's when our function is at a local maximum or minimum. Okay. Again, the red, so we follow the red, we're back at 0, our function is at a minimum, and then as we increase, we're back to a big positive gradient, and that's what's happening with our function. We can ask what's happening here. Well, at this point, okay, we have a point of inflection, a non-zero point of inflection, okay? So what does that mean? Here we have a small negative gradient on our function. So our function has a small negative gradient and it's getting bigger. It's getting steeper as it goes down until it gets to this point, in which case it's as big as it's going to get. Same size here, okay? So the gradient is fairly straight between those 2 points, and then it's getting smaller and smaller. It's starting to bend out until it gets to 0, okay? So it's smaller and smaller and smaller and smaller. Now we've got a small negative gradient, tiny little negative gradient, and at that point it's 0, okay? That's what's happening with the red line. The red line is getting smaller, it's approaching 0, and so it's describing what is happening to the blue graph, okay? Then we're back at 0 at this point, and then we're back into a small positive gradient here. So this is small positive, and it gets steeper and steeper, and that's what's being shown by the red line. I hope this video helps.